Good afternoon, everyone, and welcome to PMCC's third Brain Huddle webinar of the year. It is our pleasure to have you here with us today. At PMCC, we provide project management and consulting services for a wide range of sectors globally. Brain Huddle is one of our initiatives to provide a platform for experts of respective fields to share about topics relevant to the current situation in the market, allowing you to relate the knowledge in real-life work situations. If you wish to find out more about our services, visit our website www.pmcc-corporation.com. For today's Brain Huddle session, our topic is Fire Risks Management for Business Continuity, presented by Mr. Hao-Giang, who is currently an expert for the subject matter and is currently the Principal Fire Safety Engineering Consultant and Fire Safety Engineering 𝗔𝗪𝗶𝗿. Before we begin, let us go through the house rules. You are encouraged to switch on your cameras and interact with the speaker to get the most out of this experience. Do mute yourselves unless instructed otherwise, and you can post your questions in the chat box, and then we will address them at the end of this session. And now, without further ado, I pass the floor to Mr. Teh.
Thank you, Carmen. Let me share my screen first. Can all of you see my screen?
Yes, we can.
Okay, thank you.
Yes, okay.
Now, what I'm going to share with all of you is actually a very important topic for construction industry, especially those who are managing properties, or those who are actually involved in the construction of new buildings. Yes, okay. Okay. As introduced by Carmen, I'm actually a Principal Fire Safety Engineering Consultant. I'm also President of the Institution of Fire Engineers Malaysia branch. And currently, I'm also serving as a Trustee and Board of Directors of the Institution of Fire Engineers International. Brief breakdown of my background. I'm actually a panel lecturer, CPD lecturer for professional institutions and universities, government agencies and communities in Malaysia. We look at the Pertubuhan Architect Malaysia, Institution of Engineers Malaysia. I'm also a CPD lecturers listed with Board of Engineers Malaysia and also Board of Architects Malaysia.
The screen is not moving. Okay. Your screen is frozen.
Okay. I've also been invited as speaker for international fire conferences around the world, and I've been involved in Malaysia standard development for the past 2 decades. Now, it's about 2 years ago, I'm nominated by Department of Standards Malaysia under MITI as Malaysian Fire Expert, sitting in the ISO Technical Committee Standard Development. And of late, I've taken up a project for development of international fire safety standard under United Nations. It's called Global Plan for a Decade of Fire Safety. This, I'm representing IFE Board of Directors. So basically, my whole life, I'm involved in fire safety engineering since I left university. Now my screen is on. Okay. Now let's look at fire safety fundamentals. All right. Fire safety principle is applicable for all types of building, whether it's new, whether it's old. Actually, lately our concern is about occupied buildings, because as the building is being occupied, the risk and the hazard increases over time. And since occupied buildings consist of about 90% of the construction industry, this is a sector that I think we need to actually take a look at what fire safety fundamentals are. Having said that, if you look at overall fire safety design, I think the objective should be life safety priority. Since property safety, normally all buildings are outsourced to the insurance underwriters. So life safety is actually very important. Unfortunately, regulations, codes, and standards, compliance does not guarantee life safety or property safety. If you do not consider a lot of all related factors, for example, fire behavior, smoke movement, as well as human behavior. Later on, I will tell you the reason why human behavior is actually very crucial. We can't just design according to code compliance and forget about all these important factors. Residential occupancy risk is also not covered by code and standards. And if you look at nowadays, we're building higher and higher residential buildings, especially condominiums or apartments of 20, 30, or even 40 story now due to land costs. Imagine if all these occupants were children and senior citizens is asked to evacuate high-rise buildings. What are the implications? We also need to consider modern city and city built environment, because there are different fire risks and fire hazards. And we have already experienced within Klang Valley many incidents whereby the gas leakage in the eatery area caused explosion that affected the shopping mall. Prescriptive design is what we have been following for decades. But not necessarily the best design, because nowadays we also have performance-based design for modern high-rise buildings, mega-sized shopping complex. We are looking at also very huge transport hub like our airports. What about the sports complex and the what they call public assembling, worshipping places, mosque, church? Prescriptive design is deemed to satisfy design parameters, which means that if you follow the code and standards, it means that the building you design is safe. But then there are a lot of fire incidents around the world has proven that that is not the case. One is that a lot of these codes and standards, regulations has been written and established probably about 80 years ago. At that point of time, there is no high-rise buildings, there is no, our population is not so dense, and the risk and the hazard is actually not as much as today, because we are dealing with a lot of synthetic materials that actually have higher combustibility and they burn ferociously, also created fire propagation at a speed never seen before, especially plastics. All right. So design concept could be outdated if you keep following the built environment, the code compliance regulations. So sometimes due to the changes in the design, for example, nowadays the high power storage, I've ever talked about the robotic, what they call go downs. Now, when you start to have higher racks within a go down, let's say up to 2.5 to 3 story, and if you still follow the normal sprinkler design, first of all, it's not going to be effective. Secondly, is that at times due to the smoke being diverted by the convection current within the factory, the sprinkler head actually operates not on top of the source of fire, And even though you have sprinkler system, your go down might still not be protected. So there are a lot of changes in the built environment, and I think we need to start looking at whether the current code or the regulation can actually cater for this risk. Fire hazards and fire risks are not factoring. If you look at the building we design, they only look at protection, but they never look at how much things are combustible. And normally the party that actually added a lot of these fire hazards and risks are actually the interior decorators or the interior designers, because when a building is completed, it's virtually empty. After it's handed over to the owner, upon the issuance of a certificate of fitness, the owner will then call in an interior designer, and they are the one who actually finishes or furnish the building with all the building materials, and a lot of them are actually highly combustible. But yet they are not regulated, and there's no further approval required to look at whether these furnishing or finishes are they safe from fire. And there are limitations for high-rise or mega-size project. If you look at our building regulations, they are not catering for extra travel or extra height. Plus, building regulation also does not cover firefighter safety. If you imagine, when a building is on fire, all the occupants will be evacuating from the building. But who actually spend hours in the building? The firefighters are actually entering. So are we actually protecting the life of firefighters where they are trying to save our life and property? This building that I presented here that you see in the photo is a very cruel reminder that we are still struggling with designing a fire safely. This is actually a disaster that happened in the UK several years ago. And Grenfell Tower actually taught the whole world a bitter lesson, whereby conventional wishful thinking may no longer apply. You see, all the time, we always believe that the UK is the model where we should be looking forward to. But if you were to follow the disaster and the 3 years of a court case proceedings, you understand why things like that happen. And because there are a lot of assumptions, a lot of personal opinions has been taken into designing or into assessing whether a building is safe or not. This particular building is a pre-war building. Of course, at that point of time, regulations are not properly established yet, but still, we cannot have the excuse that why subsequently no adequate or appropriate fire safety measures are being introduced. When this building was refurbished, this building actually is situated at a very prestigious area within London, because it's so near to Princess Diana's Kensington Palace. So as this building is very old, so the local council decided to actually refurbish it. They spent something like £16 million, but end up spending nothing on refurbishing of fire protection system. Fully non-sprinkler protected. There's no fire detection alarm system. And also the passive protection is grossly inadequate. So if you look at the fire brigade that comes in to try to put out the fire, you can see that the hoses at the base of the building can only reach about 10 stories. So for any high-rise buildings, we got to make sure that water supply through pumps and tanks should be able to reach all the floors above. But if you look at this particular building, the fire that actually burned the entire building, you then realize whether our current design of only catering for 3 floors on fire, is it adequate? Or should it be reviewed? Now, UK also have a very unique evacuation strategy. They call it stay put, which means that under any fire incidents, all the residents are advised to go back to their apartment, lock the door, and wait to be rescued by the fire brigade or the firefighters. But with a building that is fully on fire, eventually led to a disaster where 73 lives was lost. I watched some of the videos and I tell you, it's so pitiful. Housewife with 2 young, pretty daughters actually called the husband who is working in Dubai and left a last message that she can't evacuate because the hall outside is actually, the lobby outside is actually full of smoke and the staircase is full of smoke particles as well. Why the staircase is full of smoke particles? Why they cannot escape? They are not staying on the upper floors. So you see, there are a lot of questions that's being raised that is unanswered. So hopefully, I think we need to keep looking at past fire incidents, and hopefully we can learn from the lessons. Of course, we are not going to repeat that kind of lessons here in Malaysia. Hopefully we can learn the other people's bad lessons and then avoid with mitigation measures. Hydrant water pressure, flow and reach cannot cope with high-rise buildings, and this is already being displayed in so many high-rise buildings, fire incidents around the world. And that's why internal firefighting is very, very important. Everything else within the building was actually fully burned, despite the building is being equipped or renovated with double glazed window. Double glazed window actually have a proper insulation property, and you can imagine the ferocity of the fire caused by the external cladding. You see, when we talk about green, I always stress that green must be truly green. If it burns, it becomes brown. Now, what happened in Grenfell Tower disaster, as well as a lot of other high-rise buildings in Dubai, is that they go for green. So in the UK, they try to save energy by using insulation materials on external cladding, up to 6 inches of polyethylene foam. They are light, cheap, and easy to install, but yet when the fire started, it burns like a torch. In Dubai, it's just the opposite. Because the weather outside is so hot, they use high insulation material to reduce the air condition bill. And there are so many fires, high-rise fires in Dubai, even until today. There's another one yesterday, all right? So you can see that everything inside the apartment is burned. Nothing is left behind except concrete or brick or metal. You can imagine the ferocity of the fire. Now, let's look at human. Nobody look at how high a temperature can human sustain during a fire, or if you approach a fire. If you look at from the bottom, at 30 degrees C, that's what human comfort zone. Of course, depend on humidity and wind or the temperature. Let's say around 30 degrees, we are still okay. But if the temperature goes up to 65 degrees C, then we can't tolerate less than an hour. All right. And what is the boiling temperature of water is 100 degrees. You can see that we cannot even sustain water boiling temperature. So if you go any further to 121 degrees, if you are put in a room with 121 degrees C, you can only tolerate within 15 minutes. That's why you won't be surprised why people jump. A lot of people jump from high-rise buildings from the window because the heat is just too much. If you go to 148 degrees C, 5 minutes. And at 180 degrees C, you will have injuries to your skin. But question is, what is the temperature of normal fire incidents? It can range between 400, 500, all the way to 1,200 degrees C. If you happen to be in a fire of 1,000 degrees C, you will disintegrate and disappear, evaporated. You'll be declared mission action. These are the external cladding fire. On the left is actually Grenfell Tower. And I always say that how do you assess the danger of a fire is by looking at the temperature. 4 colors generally: orange, red, yellow, and white. The orange, probably you'll be looking at about 300-400 degrees, all the way to white is about 1,000 or beyond 1,000. So if you look at this photo, you roughly can gauge what kind of temperature is the fire on the building. For Grenfell Tower, you can see that it's ferocious. All right, most of it is white color. On the right-hand side, the photo shows the famous Address Hotel in Dubai. So if you landed in Dubai at the international airport, all you have to do is to tell the cab driver, take me to the address, and they'll send you to this hotel. It's so famous. And this hotel actually situates right across from the tallest building in the world, 𝗔𝗯𝗂𝘁𝗁. Again, both of these is caused by external highly combustible cladding. All right, so around the world, so many cities make the same mistake, going for green, and at the end have to pay a very hefty price. Now, when this Address Hotel fire happens, it's so coincident it happened on the New Year's Eve. And normally tourists flock into Dubai on the New Year Eve because Dubai, 𝗔𝗯𝗂𝘁 always have firework display and attracted a lot of tourists. But on that New Year Eve, all the tourists got two shows, one live show and a firework show. My friend, who is a fire chief at that point of time, told me it's hell, you know, because he got to deal with the evacuating the residents and as well as controlling the crowd. We talk so much about high-rise fire risk. Is it true? To me, fire doesn't recognize whether it's high-rise or low-rise or whether you're rich or the poor. When it happens, they come after everybody. This is again low-rise fire below 18 meters. This is a Boston student's apartment. And you can see that they did not use the polyethylene foam insulation, yet they use high-density panel board as the cladding, and the result is the same. All right. So we should not be looking at only synthetic materials, but also looking at combustible organic materials, wood-based. Now, what is happening is actually quite scary, because when a fire happens, normally the code assume that everybody on hearing the alarm will leave the building. Is that true? It is not. First, according to international statistics, 85% of occupants ignore fire alarm because everybody thought it's a false alarm. Secondly, in the modern era, everybody got a smartphone. When you see a fire incident, what do? Instead of evacuating, everybody move towards the fire, try to take photos, videos, and went viral on their social media. So you see, human behavior, if we do not take that into consideration, you cannot claim that you design a building safely, even though your fire detection alarm system complies with codes and standards. All right. Fire, again, if you look at the color, I don't have to tell you. All right, it's ferocious. All right. Now, if you look at the modern city, it looks fantastic. Aesthetically, I do agree, you know, it looks modern and beautiful. But are they inherent fire risks? Because once you have this curtain walling system, potentially you're actually designing an external chimney. Because there is always a gap between glass curtain walling and the horizontal floor. And normally this gap, where they put the bracket and install the glass panels, are not properly sealed. So whenever you got a fire, the fire could have break through this particular gap and then spread horizontally. And worst of all is that now they're being guided by the glass panel, and then many of the floors above will be affected as well. So building regulations stipulates a minimum fire safety requirement for authority compliance. And that is where a lot of designers basing on that as the fire safety norm, which again, I think you have to assess whether what is the occupancy risk of the building, what is it used for, and how many people are going in. For example, I give you an example whereby my friend, engineer, tell me, wow, this building, 6 stories, I design everything according to code and standards and regulation. I said, are you sure it's safe? He said, yes. I said, but I don't think occupants can evacuate. He said, why? I said, you design the alarm bell, but this is the headquarters for the association for the deaf. You have the alarm bell, the deaf people can't hear. So is it safe? So you see, there are a lot of considerations to look at the eventual application of the building against what is being designed. All right. Prescriptive code, I'm not saying that you can't use. Yes, but we cannot stop at what is being listed inside that document. A well-designed fire detection alarm system, effective in evacuation of a building on fire. I can talk about this for probably the whole day. All right. This is a very, very important what I call that topic, because this is the first line of defense in any building. System must be able to pick up fire at the earlier stage and then raise the alarm to make sure that people evacuate. If it fails in its purpose, then you know that we're going to have a problem. But they are more into that, because you've got to actually incorporate acoustic engineering. You've got to understand, because you're looking at sound traveling through the air, entering a human using the ear to detect the sound pressure level. I won't go into that because I got no time for it today, but then perhaps in future. And then are occupants being briefed about the fire safety measures in buildings? But if you look at, let's say, commercial buildings, I can tell you 𝗪𝗪𝗂𝘁𝘂𝘁 actually did a very good job. All right. They do have an evacuation program, and all the residents were briefed in advance of what are they supposed to do in times of different fire scenarios, and they also conduct drills. All right. I went through drills with them, the safety program for many times, and they are really, really well prepared. But I believe majority of the buildings don't do this. Are all fire protection systems maintained in full operation conditions? You know the answer, because maintenance doesn't seem to be a culture in Malaysia. Thus, fire risk assessment and management carry out annually to address a change of risk. Building risk change every year. Look at your own house. When you buy is new, there's nothing inside until you start stacking up your old magazine, your, what do you call that? You buy a lot of things, you know, a lot of plastic cabinets and all that. The risk increases over time. Yeah. But yet commercial buildings, nobody do a risk assessment. And yet we are building taller and taller buildings. Look at, I'll show all these tall buildings, and this particular building has been taken for what they call technical tour all the way to the top. And I tell you, they have quite good what they call preventive measures. They even have mechanical floors whereby the water tank can use to flood the floors below if the fire gets out of control. This is 452 meters. Let me ask all of you questions. If you are 452 is about 160 floors. Can you walk the staircase down in one go during a fire drill? You can't. So you see again, human behavior, human physical limits are not taken into consideration. Except for Malaysia, we are very proud because Petronas Twin Towers happen to have a sky bridge linking the two towers. So the height of Twin Towers actually is only 41 floors. Now, if you look at the left, Tower 2 is on the left. If a fire happens on the lower level, all the up to 41 floor, everybody be asked to go into the staircase and evacuate. But from 41st floor onwards, everyone will be asked to come down if the fire is confirmed. Come down to the sky bridge, cross over, and they'll be taken down by high-speed lift. So it's mechanical assisted evacuation. But how many commercial buildings actually go deep into establishing ERP, ERM, and ERT? You're building higher and higher. Look at this 84 meters. This is Hong Kong International Commerce Center. In fact, this was actually designed, the fire protection was designed by one of my peers in Hong Kong. And if you look at there are breaks in between where you can see on the facade where you see the breaks. One of it is all these are actually refuge floors, whereby if you walk down and if you feel tired, you can actually take a rest. This particular floor, there's nothing combustible. It's actually for people to take a rest, and then you can continue your journey. So when Engineer Wong took me around, I asked him a question. I said, "You're going to have so many people, sitting around, and who is going to look after them?" He said, "Firefighter." I said, "No, firefighter's job is to actually do search and rescue and firefighting." So I said, "You need the management people to actually look at this." But having said that, I also tell him, human behavior is like that. You walk down, and especially for those who do not do exercise often, you feel tired. Some of them, seniors probably the heart will be pumping and they will be painting and all that. And once you sit down, you feel so comfortable. Do you think you ever get up and walk again, knowing that you've got another, 60 floors to go? Answer, of course, is no. So how are you going to deal with all these people who is going to stuck, hundreds of them stuck at all these refuge floors? So you see, we should not be actually trying to solve a problem by creating another problem. Shanghai World Finance Center, 492. This is 101 story, and in Malaysia now we got one building that is already 106, and Merdeka building got 118. Of course, Merdeka 118, they have a scheme, evacuation by lift, but then again, that will need to be tested. I still believe the staircase is still the life for evacuation, because if you depend on mechanical, unless you actually maintain it properly, and you need a proper evacuation program. While this Shanghai World Finance Center was under construction, I was taken up to Jingmao building, the one on the left, and then we went up to the top to take a look at the construction. It's very interesting. And even Jingmao building are very well designed. We went through safety briefings. They have actually a hotel, 5-star hotel on the upper floor of the building, and it's beautiful. But again, I pointed out a lot of risks based on my experience. Look at the hotel. This is on the upper part of Jingmao building, and you can see that internally it's actually empty. The bubble lift going from I forgot which floor all the way up. I think 46th floor all the way up. So if you have a fire in one of the rooms, I'm quite sure the smoke, everything will be spilling upwards. Taipei 101. When I was taken up this building for a visit, I actually asked a question to Taipei Fire Rescue Chief. I said, Taipei is famous for tremors. Why are you building so high? And then, of course, the consultant actually explained that if you look at this building, it's very stable. Upper part of the building consists of 8 boxes, and these boxes is actually have a narrow base and they sit on top of each other. And then when it comes down to the base, it's actually trapezoidal, so that the base is in broadened, and the if you look at the structure, it's actually double design compared to the normal buildings. Speed is very high. And what actually surprised me is that normally for high-rise buildings against tremors, they will have 2 water tanks on the top transferring water during the earthquake, so that to prevent oscillating of the building resulting in collapse. But in this Taipei 101, instead of having the water tank, they actually designed a ball that is 30 feet in diameter, a steel ball, and acted as a pendulum. This is another building in Saudi, 600 meters. And this is the tallest at the moment, but in probably, 3 years' time, you'll be replaced by 1 kilometer building in Saudi. But the question I'm asking is, why are we going higher and higher? What is the objective? You spend billions of dollars, and if you look at the top, the usable area is actually very limited. Except that, it's good for filming Mission Impossible movies. I was taken up actually all the way to the observation deck, 600 meters, and everything looks so small, like ants. And the buildings I'm looking at are all actually high-rise buildings. When I was invited to give a talk in the fire safety conference, I raised a lot of concern about high-rise buildings, and during the tea break, three participants, the Arabs, approached me, looking very, very concerned. Mr. Tay, you talk about high-rise buildings and all this, and he said, I just bought condominiums up there. So how do I evacuate with my kids, very young kids? So jokingly, I told him, how many of you? He said, 2 of us, me, my wife, and 2 kids. I said, good. Go back to the developer and ask for parachute. Open the window. I said, outside our desert, very safe to land. It's a cruel joke, but then, you know, question I'm asking is, why do you want to buy so high? And most of the time, do you know that the Dubai was covered by cloud? So I said, you see nothing except white. And yet, you know, there are actually risks if you stay too high. It's actually beautiful. Just now, the address hotel I show you is actually directly opposite Burj Khalifa. And below that, actually, they have the 2nd largest shopping mall in the world. And I tell you, you want to go in there, make sure you have a waist. Because everywhere is like a maze. This is, if you look at Pavilion and Mid Valley, it's nothing compared to them. I'm telling you. And everywhere looks the same. All right. And I also actually do a risk assessment, and I could hardly find any exit sign. They don't have keluar. They use EXIT. I could hardly find exit signs. It's really scary. This is a one kilometers building proposed. I don't know whether it's going to be continued, but then I don't know. I rest my argument of why they are competing with each other. Fine, but what is the objective? Fire safety engineering design actually should be adopted. All right. You look at fire safety principles. You look at applied fire and smoke behavior, human behavior, proper compartmentation. That means you really need fire stopping, not the make-do fire stopping by a lot of developers where they want to actually save money. So big floor opening, they use cement and sand mortar to cast it until a small slot. That is not proper. Fire will still break through. So you need proper fire stopping system tested by laboratories for compartmentation. And you need performance-based design, which means that at times you also need computer modeling. And you must be verified. All computer modelings must be verified and not just use computer modeling to actually generate reports. Evacuation, I think, is very important. As I pointed out, at the moment, we are still using a single evacuation speed of 1.12 meters per second. I always joke that, if you were to use that, that means you're assuming that all Malaysians are 20 years old with the same leg length to be able to achieve the speed, all right? But then we have so many different kind of people. And we have to balance security and safety. Many hotels in Malaysia actually remove the lock set handle when you enter the staircase, which means that once you go in, it's one way down. You cannot re-enter the building, which is a high risk. Because if you enter the staircase and then there's no way of going back to the building on several floors down, when you see smoke coming up, you'll be trapped. And this is against our building regulation. You need to establish emergency response planning, ERP, and then you need to manage it, ERM, and then you must have your own first responders, emergency response team within your building, because Malaysian Fire Rescue Department already deregulate since Datuk Seri Ong Kating's time. They cannot respond in time, all right, because it could be due to weather, could be due to traffic jam, or could be due to the overdevelopment of the cities. So building owners under designated building under Fire Services Act must be self-sufficient. Then, of course, fire and risk management and assessment is now a necessity, no more luxury. All right, because a lot of people thought they can claim insurance, but then insurance also have a lot of exclusion clauses, and you need preventive maintenance. These are fire stoppings, where any openings within the wall or the floor inside the building must be properly sealed. All right. At the moment, all these are the issues facing construction industry. Descriptive code with no specific fuel load. Interior designer added significant fuel. Fire risk changes with time, maintenance is not done, change of occupancy risk. There are buildings whereby it's under lease, so the turnover of the tenants is so high. I saw a office building being leased out of 3 floors to a telco company where they bring in tons and tons of communication cables. This actually added a lot of fuel load to the building that's not designed for. So if the original building has sprinkler system, they cannot actually protect the building. Look at this beautiful structure. It's in Dubai. It's the Future Museum. And I tell you, if you go through the entire paper about how it was designed, how it was constructed, you'll be amazed. All right. They use very advanced aviation skins to actually construct the exterior of the building. And when I was there, it's under construction. And this is a photo I've taken myself. That is beautiful. All right. There is actually a YouTube video. You can actually go and take a look. Let's talk about evacuation. And Dubai is the place that want to attract a lot of foreign investors, and they started to have these funny design buildings. Now you tell me, how can you designate your north fire escape staircase from your south? Because the building is being twisted. All right. Singapore Marina Bay Sands actually adopted a performance base, and you can see that, you can see that there are actually requirements stated in the bylaw that is being omitted. For example, if you look at, they have very high atrium, so sprinkler actually can't operate. So there's no sprinkler in the atrium, and there's no smoke extract system, because this is big enough to serve as a smoke reservoir. The issue with smoke reservoir is that as long as you can provide clear smoke height for occupants to evacuate, then you can deal with the smoke accumulation later on. So Arup is actually the designer for the M&E, and I'm quite impressed with the way they adopt the performance-based design. This is a CCTV headquarters in Beijing. This is one of the building design that achieved an award. You can see that it's designed like a door, a Mandarin character door. And they also have the head office here, all right? And this head office, once completed, before it came into operation, they actually allowed it to be used for firework display during Chinese New Year Eve. And because there's no proper safety protocols, you can see that eventually the whole building was burned. Contractor is very happy. We get two projects cost instead of one. Imagine. And the inside here, it also houses a 6-star hotel. There are actually landmarks being built. All right. This actually, Dubai, they have tons of money from the ground. So they built this landmark that actually, they call it a Dubai frame, whereby tourists can take a lift up here to the high level and look at the beautiful skyline. The way that is, this is Burj Khalifa, all right? But again, if you have all these people, tourists on the top here, how are you going to evacuate them? Safety is always an issue that has to be addressed. Okay, let's look at human behavior. Humans are irrational, and worldwide statistics point out that not many of them respond to fire alarm. Egress speed differ for different age group, yet up to now, architects still use one standard speed. So what does it mean? Is it realistic, or is it actually fulfill the type of calculation that you can fulfill the approval from the authority? And then normally, if you ask people, if they don't see fire or smoke, the assumption is there's no fire. That is very dangerous, all right? Because nowadays smoke propagation is so fast. And not only smoke particles are carrying high temperature, they also comes with toxic fumes that kills. If you look at the Twin Tower 911 disaster, there's a couple that actually is evacuating halfway, and then the message came in says that the fire incident is under investigation. So the wife told the husband, say, darling, you go down first. I think I better go and finish my report for the director. So she went back up to the office. And after that, of course, what we all know that the building collapsed. So my advice is whenever there is a fire alarm, whether you're in the building, high-rise building, office, or especially in the shopping center, evacuate first. All right? Good exercise. And if nothing happens, you can still go back. But if something really happened, maybe you save your life. Now, when we design the fire alarm system, we never consider the age-induced hearing loss. In fact, if you look at a lot of factories or any area that the ambient noise level exceeded 70 dBA, is mandatory OSHA will require for anybody to wear ear protective headphone, muffler, or earplugs. Imagine if you're working in this area, the ambient noise level is so much higher. And if you put in a earplug, do you think you can hear the fire alarm? Answer is no. But yet still the design goes normal. So there are a lot of inadequacies in our code and standards that I think we have to seriously review. Fire resistant door sets are actually, fire alarm and door sets are my favorite topic because these are life-saving elements of a building. If you look at the photos, you see that a fire happening outside the room, and if the fire door is being closed, then you prevent fire and smoke propagation, all right? And these are very crucial because they are critical compartmentation element. And they enable egress, yet stop fire propagation, but they are so crucial because when you install a fire door, means that the wall around it is fire rated. If you left the door open, which I can see most of the shopping complex and some of the offices, they even use a fire to use as a doorstop, that is really silly, okay? If you keep the door open, then why spend money installing the door? Might as well do not install the door. Because a lot of people don't realize that the door, the importance of the fire resistant door set is to actually provide compartmentation, right? If you talk about pressurization in any high-rise fire escape staircase, don't forget that every floor there's a fire resistant door set. If you do not maintain, and Malaysia, as I said, nobody maintains fire doors. If the doors cannot close properly, or if the door is left open, imagine the smoke will get into the fire escape staircase and nobody can escape. And there are a lot of components in the door. If you go through, you can actually go and take a look at the Malaysian standard 1073, part 3, 1996, with Amendment 2003. It's all listed there, all the components. You have door lift, your lock set, your door closer, your hinges, auto bolts, door selectors, and all that. Can the fire resistant integrity of fire door be maintained? That is a $1 million question, all right? Because Malaysian fire resistant door sets are only tested to 100,000 cyclic movement. That means we actually perform the duration or the performance of a door, and we are the only country in the world. Go and check the rest of the standards, country standards, they don't have. Malaysia is the only one that tests to perform the door. So the question is 100,000, how long can the door last? Because door is the only building element that's subject to wear and tear. If you look at floors, walls, columns, beams, they are static. Can be there for the next 20 years. But doors are actually subject to opening and closing traffic. Sometimes they are abused, you know, when the cleaners come along and bang it with the cuts and all that. So how long can a fire door last? In fact, if you look at Malaysia, there's no deadline for doors or lifeline for doors, and it can be there for the next 30 years. But at the end, we have to really look at it, that are they still classified as fire doors? I've actually did research together with the student when I was lecturing in the UIA. And we find that the 100,000 sometimes only lasts probably about 2 months if the door is used so often, all right? 100,000 divided by 10 years, assuming the door lasts for 10 years, lifespan, That means 1 year, the door can only open 10,000 times, right? 100,000 divided by 10, simple arithmetic, 10,000 times. But divide by 365 days, that means that every fire door can only open 27.4 times a day. Shopping complex, one of the doors that we do measurements, goes up to 3,685 days, opening and closing. You can do the calculation, you know that that door can't last 10 years. There are different types of doors for different application as well. All right, these are actually for emergency exit. If you go into a hypermarket and all that, they use this. This is called automatic panic exit device. That means you do not need to operate the lock. When the body or your arm touch the panic exit device bar, the door opens by itself. And yet I find that a lot of exhibition centers, they lock up these doors with padlocks. This is another situation where, you know, if you look at this, it's actually a hazard. It's because this is actually another, I think it's a services room, and this door can be actually opened during a maintenance. Imagine this is actually a design egress route. If this door is kept open, you will obstruct the escape route. And doors has been tested. And you can see that Cerium conduct open market sampling tests of doors that already been tested and are on sale on the market. And one of these doors failed at 42 minutes, where it should actually last 60 minutes. Means of escape nowadays, because we are building bigger buildings, we are building mega-sized shopping complex, and the amount of the density of the population inside these buildings has increased tremendously. Now, the question is, can we evacuate all these people during a fire incident? If you happen to be in a theater and all that, do you think you can get out, especially for those who would like to sit in the middle? If you're sitting on the aisle, you can get out quite fast, but if you're in the middle, what about when everybody is accumulated at the limited exit point? There will be a crowd. And would there be a stampede? So nowadays, for means of escape, there are actually many areas we have to look at. We have to look at compartmentation so that the fire, when it happens, can be contained inside a room so that there are time for people to evacuate. And what about maximum travel distance? You need alternate and protected egress routes. We will look at the end limit and many other systems. This is an area that I have been talking about many times, whereby if you look at all these, what they call evacuation signboards in any building, they are actually having too much information there. You got no time to actually read all those. All you need is to indicate clearly which way to go. And I think this is a modern design that is very fitting. They even tell you the direction. Because all you want is, where should I go to get out of the building during a fire? In China, they even have permanent exit sign on the floor, permanently illuminated. All right. We always say China is behind time. Look at their airport, look at their shopping complex. And make sure that you follow the right arrow, because they are also 70% discount arrow going to shops. My professional peers are now designing basing on the assumption that fire can only happen in one place or one floor at one time. Again, I told them that's wrong, because 25 years ago, there are already cases that happened in Hong Kong. First case that the fire spread from 4th all the way to 14th and 15th floors. And that one took about kills about 42 people. This is Lakana building in the UK that actually, you can see the fire spread, lift the rest of the floors. So there are a lot of reasons why this happens. And so we cannot base on the old wishful thinking or considering fire happening in one place only. Of course, that's the easiest design, right? But question is it fit for purpose? These are other what do you call it, modern evacuation signboards, right? You can see that it's all painted green. It's very easy to read. Where you are, blue, right? Now, this is another point I've been raising. We always ask to put the keluar sign on top of the door. During a fire situation, do you think you can see the keluar sign? Actually, it's here, all right? So why are we still putting it up there? Secondly, is that the 𝗪𝗯𝗂 now are all made of plastic, no more metal casing. Do you think they will still be around? Because plastic casing, smoke particles carry about 250 degrees, 100 to 250 degrees, they will destroy the 𝗪𝗯𝗂. If you look at Norway, Finland, they are now putting the illuminating sign on the carpet itself. They do not need to put it on the wall. These are the refuge floors that I talk about in Hong Kong. In China, Hong Kong, Singapore, if your building exceeded certain height, you need to actually incorporate refuge floors. Nothing combustible, everything is protected. You can take a rest, but as I say, the problem actually started because how are you going to deal with all these people who are resting? Let me show you a video. Simulation,
Please evacuate this building.
Prevention is better than cure, definitely. During a fire, you have fire damage and water damage. So fire safety for occupied buildings, you have to look into a lot of considerations. I will not run through it. And to sustain fire safety, of course, you can understand the danger of heat, smoke, toxic fumes, carbon dioxide, water vapor. And the last one is the most important because any fire will produce carcinogen byproducts. Carcinogen means that if you inhale some of these gas, you will then develop cancer in your lung. All right, that's very important. For forward-looking, I think we need to review building regulations, code and standards, application of base testing methodology, because a lot of the test method in the lab is already outdated. Beam, fire dynamic combined with egress simulation, I think now is the in thing. All right, intelligence fire detection alarm system linked to mobile apps, because important thing is that we do not want to just rely on the bell. We need to actually use the apps more to actually get everybody and inform everybody of what is actually happening, who should be evacuating and all that. 5G and AI for accurate sharing of fire size, material data and all that, I think is very important. There's a future that's coming. Face detection for head count, occupancy localization. For intelligence building, they are doing it now. Wireless plug and play detectors, MCP. Integrated home intelligence system for high ambient smoke detection, robotic firefighting systems. There are endless, new technology that we can actually incorporate. The last one is very interesting. Exoskeleton suit to aid firefighters and people with disabilities like transformers is already being looked at by Singapore Civil Defence Force. So that is all I have to share. I think time's up. Open back to you, Carmen, for Q&A. Thank you.
Thank you, Mr. Teh. So as Mr. Teh has mentioned, right now we will do a quick Q&A session. Understand that the time is already 4 p.m. We wouldn't want to drag too long as well. So if you guys have any questions, please post them into the chat box.
Or you can send an email, all right?
Okay. All right, let's give them a minute to type in the questions if they have any. Mr. Chia says, thank you, Mr. Teh.
Thank you. Hope you all learned something today.
All right. Okay. Then I guess there are no questions. Just an announcement for our participants. You guys can actually find our recording that will be published on our YouTube channel. It will take a few days, but please follow us on our social media platforms and then you will be able to catch the update. Thank you so much. And that's the end of our webinar for today. Thank you, Mr. Teh. Thank you, everyone. Wish everyone Selamat Hari Raya, safe travels, and happy weekend.